Scatterplots. Scatterplots are a graph that have a lot of dots, where each dot represents one piece of data. So in this case, we have months after January 2011 down here and the consumer price index on the Y. So those are the two pieces that we are graphing here. Now, what is the independent variable? Well, as you know by now, the independent variable runs on the horizontal axis, and so the independent variable is months after January of 11. I don't know why I put a 0 there. And what's the range of values for those? Well, starts at 0, goes to 70. So 0 to 70, and those are in terms of months. We're going to get to that again later. What's the dependent variable? Well, that's on the vertical axis, so CPI. And what range of values is represented there? Well, it's hard to see because I crossed it out, but 215 to 240. And those are the range of values for the CPI. All right, now a positive trend occurs when as one variable increases, the other variable also increases, and it goes kind of like this. If you have a negative trend, as one variable increases, the other variable decreases, and it looks like this. So, using the names of the two variables in the scatter plot above, describe the kind of trend. Well, as the months after January of 2011 increase, the CPI also increases, so we have a positive trend, right? And you can usually tell by looking. It's going up, that makes it positive. Positive is an increase. Negative is a decrease, right? You can tell by looking. Now, you can see now that we have this black solid line drawn in. We call that a trend line. Sometimes we call that a regression line. Excel does this very well for you. And when you do that, it will spit out this little box of data. Well, if you hit the right button in Excel. So you can see that we have a linear model, and we can use that. Okay, so we're going to use this data to answer a couple questions. So number 6, state the slope of the linear model and interpret the meaning. Well, remember, the slope is in front of the x value. Now, I'm going to put that over 1 so that I can make sure we do this. Remember, y's are on the top. The y's represent the CPI, and the x's represent the months after January of 11. So here's what this means, and I like to write it as a fraction so that I can write my meaning a little easier. The slope is positive, so that means the CPI, because that's what it represents, increases 0.246 for every 1 month after January of 11. So see how I did that? I used my labels. CPI, it increased because it's positive, increased this a month for every 1 month after January of 2011. So I'm a big fan of writing the slope as a fraction in numerics and then labeling the top and the bottom y's over x's, and that allows me to write my sentence pretty easily. What CPI does the model predict for January of 2011? Now it says model. Model means equation. So in 2011, x is 0. So if I would use y equals 0.246 times 0 plus 224.85, right? 0 cancels out. My model predicts 224.85, right? Great. Now you can see the actual is way less than that, but that's where my model is, and that's the prediction for my model. And we know that the model is just an estimate. Let's use the equation to estimate the CPI in January of 16. Now, this is January of 11. 16 is 5 years later. How many months is that? Well, 12 months in a year. That means my x value is 60, right? This is January of 2016. So I'm going to plug in y equals 0.246. I plug in 60 months plus 224.85. I multiply, and I get 14.76 plus 224.85. I add those together, and it estimates 239.61 for a CPI. But again, you can see here's the prediction up here. The actual is a little bit less than that, which is positive. All right, the actual CPI. Okay, so we did the estimate at 239.61. The actual was 236.916. Should the model give the actual value? No. The model is an estimate. That's one thing you have to remember. The model is simply an estimate. I mean, look at the picture. You can see the data goes super up and then down and up and down. It's not going to be accurate. Should you be in the ballpark? Well, yeah, it should be close. If you're not close, then you have bad data to approximate. So you should be in the ballpark, but no, it's not going to give you the actual value. All right, the last concept in this video is the scope of the model. Now, the scope of the model refers to the range of values of the independent variable of what you can reliably use to predict. It doesn't make sense to predict 30 years in the future, or maybe not even quite that far, because so many things can change. So you only want to, predict out, maybe a couple months. When you think about like IBM or those big companies, Apple, they might predict 1 quarter of profits out. We predict we will do this next quarter. You don't hear them predict in 2030 we're going to be a gajillion-dollar company. Too many things can happen between now and then. So you really want to kind of use, the scope is the actual, maybe somewhat reliable time frame in which you can predict. So we generally talk about the scope being, just a few out. So this goes, I think, to 64. We can estimate 6 months out, right? So the scope of the model really is from 0 to 70 months after January of 11. And you might think, well, why would you want to estimate between when you know the actual data? Well, this line might be published somewhere where the actual data might not be. I mean, where you can find it easily. And so maybe using the model to approximate something is just quicker and easier. I don't know, I'm making crap up as I go, right? But not everybody has this information. I never even heard of CPI until I started teaching this class. I mean, I knew there was inflation, but I didn't know how it was figured or anything because I've just never been interested, which is dumb because it's money out of my pocket. You would think I'd be interested, but whatever. So I got off topic there. Okay, so would it make sense to estimate the CPI in the year 2030? Well, if you think about it, 2030 is 19 years after 2011, right? Because that's where we started. And if we take 19 years times 12 months in a year, that's 228 months. We're here at 70. Think about taking that out to 228. Too many things can happen between now and then. So would it make sense? No. No, not at all. That is outside the scope of this model. And that's all that you'd really have to say is it's outside the scope of the model. And that is an accurate and acceptable answer if they want you to predict something that is too far out.